In the name of Allah, who is most beneficent and merciful, my name is Habiba. I'm from Chemistry Department and I'm going to deliver presentation of organic chemistry. Topic of my presentation is explanation of two named reactions. First is Gabriel Phthalimide reaction and the second is Wittig reaction. First is the introduction of Gabriel Phthalimide synthesis. The Gabriel synthesis is a chemical reaction that transforms primary alkyl halides into primary amines. Traditionally, the reaction uses potassium phthalimide. The reaction is named after the German chemist Sigmund Gabriel. In this method, the sodium or potassium salt of phthalimide is alkylated with a primary alkyl halide to give the corresponding N-alkyl phthalimide. Upon workup by acidic hydrolysis, the primary amine is liberated as amine salt. Alternatively, the workup may be via different procedure involving reaction with hydrazine. This method produces a precipitate of ethyl hydroxide along with the primary amine. Gabriel synthesis generally fills with secondary alkyl halides. The first technique often produces low yields or side products. Separation of the hydroxide can be challenging. For these reasons, other methods for liberating the amine from the phthalimide have been developed. Even with the use of hydrazinolysis method, the Gabriel method suffers from relatively harsh conditions. It has its own specific conditions. So mechanism of the reaction, the main point in the mechanism is phthalimide is acidic, and then we see how the cleavage occurs in this reaction. Then the other reaction is Wittig reaction. The most important use of yields in the synthesis comes the reaction with aldehydes and ketones, which are initiated in every case by equivalent binding of the nucleophilic alpha carbon to the electrophilic carbonyl carbon. While lights react to give substituted alkenes in a transformation called the Wittig reaction. This reaction is named for George Wittig, who was awarded the Nobel Prize for this work in 1979. A principal advantage of alkene synthesis by Wittig reaction is that the location of the double bond is absolutely fixed, in contrast to mixtures often produced by alcohol dehydration. So it has some applications. So preparation of olefins. Wittig reagent provides a method for the synthesis of olefins. And the second is the reaction is still a relevant area of the study today due to its selective capabilities and ability to be performed in the moderate condition. So it is the mechanism of this reaction. Step 1 is nucleophilic attack by the carbanion on the carbonyl carbon to form a cyclic intermediate called oxophosphatase. And the step 2, decomposition of the intermediate due to the breaking of the carbon oxygen and carbon phosphorus sigma bonds to form a new carbon-carbon pi bond, which results in an alkene formation. So it was its mechanism. In short explanation of two reactions, Gabriel Phthalimide reaction and Wittig reaction.